Today is November 25th, 2025. In our quest for a cleaner planet, we often look to the sun and the wind. But what if one of the most powerful solutions lies hidden within the Earth itself? The demand for energy is growing every day, and the urgent need to stop climate change is pushing us to find new, cleaner ways to power our world. For decades, nuclear energy has promised carbon-free power, but concerns about safety and radioactive waste have held it back. Now, a breakthrough in the Gobi Desert could change everything. China has built the world's first operational thorium molten salt reactor. Unlike traditional reactors, this one uses thorium dissolved in molten salt, a technology first explored in the US, now perfected by Chinese scientists. This isn't just a scientific milestone. It could transform the global energy landscape. We'll explore how this reactor works, the milestones China has achieved, and the advantages it offers, from abundant fuel to built-in safety. This is more than a new power plant. It's a story of human ingenuity and a sustainable future. Imagine scientists and engineers working for years in the desert, pushing the boundaries of nuclear physics to create something fundamentally better. Their success could provide a blueprint for countries worldwide, helping us move away from fossil fuels. This is the story of China's Thorium Reactor, a technology that could truly change the world. Let's dive in. So, what exactly is a thorium molten salt reactor? Unlike traditional reactors that use solid uranium rods and high-pressure water, the thorium MSR uses liquid fuel, thorium dissolved in molten salt. This liquid acts as both fuel and coolant, circulating through the reactor core and carrying away heat. The design is inherently safe. Since the fuel is already liquid, there's no risk of a meltdown. The reactor at the heart of this story, the TMSR LF1, is a 2-megawatt prototype in the Gobi Desert, built by the Shanghai Institute of Applied Physics. It's a real-world testbed for this technology, validating everything from materials to chemical processes. Thorium itself isn't fissile, but when bombarded with neutrons, it transforms into uranium-233, which can sustain a chain reaction. This means the reactor breeds its own fuel as it operates, making it highly efficient and sustainable. The molten salt design also allows for continuous removal of waste products, keeping the reactor running smoothly. In essence, this is a reactor that creates its own fuel, operates safely, and could run for years without shutdown. It's a radical departure from the nuclear reactors we know. The potential for efficiency and safety is enormous. That's why the world is watching. Let's look inside this remarkable machine. The process starts with thorium and a starter fuel, dissolved in molten salt, flowing through the reactor core at over 700 degrees. The starter fuel initiates a fission chain reaction, releasing energy and neutrons. Some neutrons split more fuel, while others are absorbed by thorium, starting the breeding cycle. Thorium-232 absorbs a neutron, becomes protactinium-233, and then decays into uranium-233, the real fuel. This cycle means the reactor is constantly creating new fuel while generating power. Unlike traditional reactors, waste products are dissolved in the salt and can be removed continuously without shutting down. This online cleanup keeps the reactor efficient and reduces downtime. The heat from the core is transferred to a secondary salt loop, which drives a steam turbine to generate electricity. The entire system is closed, controlled, and designed for maximum efficiency. It's a self-sustaining loop. Abundant fuel, minimal waste, and continuous operation. This is nuclear power, reimagined. And it's working right now in China. China's journey from theory to reality is marked by world-first achievements. In October 2023, the TMSR LF1 achieved first criticality, the moment the chain reaction became self-sustaining. By June 2024, the reactor reached its full operational power of 2 megawatts, proving stable, safe operation. In October 2024, Chinese scientists refueled the reactor without shutting it down, a key advantage of the molten salt design. This online refueling eliminates costly shutdowns and boosts efficiency. Most recently, in November 2025, the team confirmed successful conversion of thorium into uranium-233 inside the working reactor. This closed the loop on the thorium fuel cycle, proving the reactor can breed its own fuel. These milestones establish China as the world leader in this transformative technology. Each step has validated the science, the engineering, and the promise of thorium MSRs. The world is taking notice. China has set the pace for the next era of nuclear energy. The future is here. Why is China investing so heavily in thorium reactors? It's about energy security. China imports over 80% of its uranium, making it vulnerable to global market shifts. But China has vast domestic reserves of thorium, enough to power the nation for centuries. Switching to thorium means energy independence and stability. Thorium is more abundant than uranium, often found as a byproduct of rare earth mining, which China already leads. Nearly all mined thorium can be used as fuel, unlike uranium, which requires costly enrichment. The reactor itself transforms thorium-232 into fissile uranium-233, eliminating the need for complex processing. This makes the fuel cycle simpler, cheaper, and more accessible. Thorium could power civilization for thousands of years. Safety is the biggest concern with nuclear power. The thorium MSR is designed to be meltdown-proof, thanks to passive safety features. If the reactor overheats or loses power, a frozen salt plug at the bottom melts, and gravity drains the liquid fuel into secure tanks. Spread out, the fuel can't sustain a chain reaction and simply cools down. Unlike traditional reactors, there's no high-pressure water system. Molten salt operates at normal pressure, eliminating explosion risks. Dangerous radioactive elements like iodine and cesium stay chemically bound in the salt, not released as gas. Even in a leak, the salt solidifies, trapping radioactivity. These features make catastrophic accidents virtually impossible. The design is fundamentally safer than anything before it. Public fears about nuclear disasters could finally be put to rest. This is a new standard for nuclear safety. The MSR's chemical and physical properties work together to contain any risk. It's a game changer for public trust in nuclear energy. The thorium MSR isn't just safer, it's cleaner and more efficient. Conventional reactors produce waste that's dangerous for millennia. Thorium MSRs generate far less, and it's only hazardous for a few hundred years. The reactor burns fuel more completely, and can even transmute some long-lived waste into shorter-lived forms. Online refueling means near-continuous operation and higher reliability. High operating temperatures allow for efficient electricity generation and industrial uses like hydrogen production or desalination. China's next step is a larger demonstration reactor to explore these applications. Thorium MSRs could decarbonize not just electricity, but heavy industry too. This is a powerful tool in the fight against climate change. Molten salt reactors aren't new. The US built one in the 1960s, but the technology was abandoned. China revived it, investing heavily and dedicating top talent. Now, China leads the world in thorium MSR technology, with a working prototype and multiple world firsts. Other countries are just starting. The US and Denmark have small projects, but they're years behind. China's state-led approach allows for rapid progress and large-scale investment. The country is building new reactors faster and cheaper than anyone else. This gives China a first-mover advantage in a new global industry. They're developing the expertise, supply chains, and regulatory frameworks for thorium MSRs. When the world is ready, China will be selling the technology. By reviving a discarded idea, China could reshape global energy markets for decades. Despite the promise, challenges remain. The molten salt is highly corrosive, demanding new materials that can last for decades. China has developed advanced alloys, but long-term durability is still being tested. There are also concerns about nuclear proliferation. Uranium-233 can be weaponized, though it's mixed with isotopes that make handling extremely difficult. Managing the complex chemistry of the molten salt and scaling up to commercial reactors is a major engineering challenge. These hurdles must be overcome before global deployment. Still, China's achievement is a turning point. The thorium MSR offers a credible path to abundant, safe, and clean power. It could help end energy poverty, cut carbon emissions, and support a renewable-powered world. China's bold vision has reignited hope for a sustainable energy future.